Hello and welcome to the Git and GitHub tutorial series. This tutorial series is designed for developers, and what I mean by that is that it starts off in a presentation format, but it's very quickly going to move into a demonstration of how to use Git. We start off in a presentation format just so that we can get the good fundamentals, get the core ideas, so that you can have a good foundation. So what are we covering today? We're going to be going over a brief overview of the Git technology. Then we will do an installation on the Git client, which will give us a command line application called Git Bash. Just to let you know, there is a Windows GUI application that we will be covering in part 2 of the video tutorial series. The reason why we're doing the command line version first is because the GUI hides a lot of important actions, and that doesn't really help you when you're trying to learn how Git works. Once installation is complete, we will start a new project and start using the basic commands to manage our project. And lastly, we will talk about GitHub and how it fits into this equation. This is to prep us for part 2 of the video tutorial series. Here is a short list of reasons why you would want to use version control. Go ahead and pause the video if you want to read through the list, otherwise I'll be moving on. So what are the advantages of using the Git version control system? Git is a distributed version control and file management system. Now both these features are extremely powerful when you have a project that involves more than one developer. Distributed version control means that every developer has a copy of the project on their computer. This means that commands to Git are very fast and will work offline since all operations are done locally. File management is a very important feature because every developer is modifying his or her own copy of the project. We need to be able to merge these repositories together in order to get a finished product. Now let's take a look at a typical Git workflow. So down here in red is your working directory. This is where your source code will be. So as you make modifications to your source code, you get to a point where you want to take a snapshot or commit, which is basically a point in time that you want to save that you can always revert back to. In order to do it in Git, you need to promote all of your changes that you want to save into this index. It's kind of like a staging area in which you tell Git, everything in this staging area I want you to take a snapshot of. Okay, once you have all of your files in this staging area, you execute a commit command. That commit command will save a snapshot to your local repository. And basically you just follow these steps every single time you want to have a snapshot of your code. Once you have your snapshot, you can always revert back to that snapshot or look at differences between two snapshots. The remote repository we will cover at a later time. This is the end of the presentation. Now it's time to do an installation of Git and then work with Git to really see the benefits of Git. Installation of the Git client is a very simple process. Go ahead and open up your web browser. And then type in on Google Git SCM. It'll bring you to git.scm.com. And right here you can go ahead and download Git Bash, which is the command line application. You'll notice down here that there will be GUI applications that you can download, but we'll explore those on a later date. So go ahead and click that. It'll start downloading. It's 14.6 megs. I'll go ahead and pause the video and then we'll pick up when it's done downloading. And we are back. As you can see, it's done downloading. If you're using Chrome, you can just go ahead and select this button and it will start the exe, or you can actually click on the icon and open to the folder. And it most likely is going to go to your personal profile downloads folder. So we'll go ahead and double click and run this. Select yes. Click yes. Next. You can go ahead and stick with the defaults, that's fine. Go ahead and select Git Bash. Actually, go ahead and select Git GUI too. Click yes. That's fine. The default's fine. The default here is also fine. I'm going to go ahead and uncheck that. And that really is the end of the installation process. Before we start using Git Bash, there is 2 Windows options that I recommend you have on. Go ahead and go to Windows, Control Panel, go to Appearances and Personalization, then go to Folder Options, and in Folders Options, go ahead and go to View, and what I would recommend you turn on is 1, Show Hidden Files and Folders. That's going to be very helpful for explanation of Git Bash. And then the second one, right below it, is hide extensions for known type files. Go ahead and unselect that so you can always see the file extensions. Select Apply, OK, and close. So the next step is to do some configuration with Git Bash. So if you go ahead and double click Git Bash, it'll open up, and the first command I want you to type in is ls, and this will give you a list of all of the folders in the directory it's currently looking at. And based on these files, I know it's looking at if you go to Start and 3082, which is your personal folder in Windows 7, it's looking at this directory structure right here. Now most of us probably will not save our projects into this structure. We would save it somewhere else, probably closer with the IDE that we're using. So that's what we're going to do first, is that we're going to change where it first starts up when you start Git Bash. So go ahead and close this out, go to right click, go to Properties, and right now the start directory path is set with environmental variables. So we'll go ahead and delete that out, and we'll type in somewhere that you would want to hold all of your projects. So I'm going to say C, I'm going to use Oracle, and I'm going to say J projects. Make sure that's saved. So the next time I open this up, it's going to the right directory that I want. So let's just double check that. So we'll go to C, Oracle, J projects, and let's do an ls of this, and we get our 308 tube and test.txt. It does not read the metadata folder, so everything looks good there. So let's go ahead and continue on with our next 2 configuration settings. Go ahead and type in git, highlight the window, type git config -- global, and then user.name, and then just type your name. For my internet name, I'm going to use the word kit. That is saved. Go ahead and hit the up arrow key, and we'll put in email, and then I'll type in my 308 tube email, hit enter, and now those 2 configuration settings are saved. So the reason why we need name and email is that when we do a commit, a snapshot, these 2 settings will always be saved, will always be recorded with the commit. That is the end of the configuration. So let's go ahead and create a new project and start version controlling that project. So let's go ahead and go to C, Oracle, J projects, and I'm gonna go ahead and create a new folder, and I'm gonna say Git project, and I'll go ahead and copy this text file in there, and I will create another text file. So I'll just call this one readme. So if we come back here and do an ls, we should see the Git projects folder, and the command that we're gonna do now is git init and then the project name, which is Git project. Then hit enter, and you should see a result of initialized empty Git repository. So if we come back here, what you'll see is that we have this new hidden folder and this contains all of the files and references that Git needs to version control our project. And this should be a fairly small file. As you can see, it's only 80 kilobytes in size. The next Git command that we're going to go over is git. Well, actually, we need to go into that folder, so go ahead and type in cd, which stands for change directory, and then git project. And it'll recognize that we are now in the Git projects folder, and it says master because when you initialize a Git project, the folder becomes the master. That's the default branch. So let's go ahead and do an ls, and we should see both of our text files over here, which we do. Now if we do the command git status, you will notice that it will tell us that we are currently on the master branch and that both of our files are currently untracked, and that's why it's marked in red. And the reason why we aren't tracking the files yet is we only have initialized it. We haven't told Git what files we want Git to track or to version control. So we can easily do this by typing the command git add, and you can use the character dot. And what dot does is it will add all of the files that is in the Git projects folder. If you want to add the files individually, then you can do git add and then the file name, whatever it may be. So if we do git status again, you'll notice that this time it'll display in green, and it will tell you that both of these are new files, and if you want to remove them, you can go ahead and type git, and the helpful hint right here basically tells you what you need to do. Git rm remove -- cached, which is the staging area. We haven't actually done a commit yet, so nothing has been saved. The snapshot hasn't occurred yet. So if we do test.txt, oh, spelled that wrong. Let's see, CAC. And now if we do a git status, you'll notice we'll version control this one, but this one won't be tracked. Now to do a commit, go ahead and type git commit -m, which is the message, and then we'll type a message to be saved, initial commit, and this will tell us that the first commit has done. So let's check this commit, and in order to check all commits that have occurred in this repository or this project, once it becomes a Git project, most people call it a repository. So you can say git log, and as you can see, here's the author name and the email that we set at the very beginning, and here's the comment we have. So if we do a git status again, you will notice that Git is telling us test.txt is still not being tracked. So let's go ahead and add that in. So we'll do git add, and we'll just specifically say add this in. So now if we do a git status, it'll tell us this file will be tracked on the next commit. So let's go ahead and do that. Let's do git commit -m for message, and then we can say start tracking test.txt. So now if we do a git log, we'll see the initial commit, which saved readme.txt, and then up here we did a second commit which started tracking test.txt. So let's go ahead and modify the readme file. Go ahead and save that. And now if we do a git status, it'll tell us in red this has been modified. But now I'm going to go ahead and run a git commit -m and say change readme, and this is actually going to fail. And the reason why it fails is because we haven't added this back into the staging area. So every single time you do a commit, that staging area is cleaned out again. So what you have to do is you would go ahead and do a git add dot, and then do a, just gonna go ahead and come up here, do a git commit, and then write in your message. So if we do git log again, you'll see that our third commit, change readme, is actually now a snapshot. The concept of a staging area might not be very important to you if you're a solo developer, but once you start working in teams and you want to share your projects with other people, it gives you a lot of flexibility, because if you're working on two things and you've completed one of them, you might only want to share the files that you've completed. So it affords you a lot of flexibility in terms of what you want to commit, and then you only share those commits out to other people and keep the files that you're currently working on just in your local repository. Let's go ahead and do another change to test. So in test, we're going to make a change, and then we'll come back and do a git status. So you'll notice now that test has changed, and then we'll add another line to readme. And then we'll do git status again. So you'll notice that Git now knows that both files have changes, and if you want to do a commit, you would need to add it to the staging area. So we'll do that. Oops, git add, and we'll use the dot as our shortcut. And if we do a git status now, it'll give us green, but this time it'll tell us it's modified because it's already been tracking these two files. Then we can do a git commit, and then we say -m, and then we say another commit. Oop. Forgot the keyword git in front. There we go. This is the basic workflow for the Git project. So let's do one more example before we get into shortcuts. Let's go ahead and create a new text file. Come back here and we'll do a git status. It'll tell us there's a new file in here that it's currently not being tracked. That's good. And let's go in here and add another line to readme. We'll save that. And let's go ahead and do a git status again. So it'll now tell us readme has been modified and new.txt needs to be added so that Git will start tracking it. Before we do a add and commit again, let's go ahead and try a new term. We can do git diff for diff, and what this does is that it'll look at the readme file that it knows has changed, and it will tell me what has changed in there. So it notices that I have added this new line in here. Now if I do a git add readme.txt, so I have added that into the staging area. If I do a git diff now, it will not give me anything because I have added that to the staging area. In order to see the readme difference, to do a diff, I would need to do a git diff -- cached, and it would show me the same thing as if I had not put the readme into the staging area. So the only difference between those two is that I have to say cached in order to actually see the differences in the staging area. So if we do a git status now, you'll notice this has turned green because we have added it into the staging area. So let's go ahead and add the other one in. And I'm just going to use dot as a shortcut. And if I do a git status now, both of them have been added in there. And then I can do a git commit -m and then say new file and changes. And there we go. So if we do a git log, we can see changes of all of that. One important thing to know is that once the log has become too big for it to fit on the screen all at once, in order to exit this, because you'll see this end right here, you need to hit Shift Z and it'll bring you out of the text editor. Otherwise you'll be stuck in there. Before we start wrapping up this video, let's go through a few shortcut commands that you might find useful. So if you go ahead and type git log and then -- one line, it'll give you all of the commits with just the message that was used during the commit. So it'll get rid of the hash, the author. So this is useful if you just want to see changes very quickly in a very small space. Also, let's go ahead and quickly change these files. So if we do a git status, we notice those have changed. If we want to just go ahead and do a quick way to do a commit, you can say git commit -a, which will add everything in the directory to the staging area, and then you can say -m and then leave your message. And then if you do a git status again, you'll notice there's no changes. It's a clean working directory, so that commit was changed. So if you just hit the up arrow key, you'll notice the shortcut commit has been done. One last shortcut to show would be, let's quickly change this again. If you do git status -s, it'll tell you what has been modified in shorthand. So if I modify this one now and go ahead and rerun that, it'll tell us this has been modified. So these are just basically ways to save screen space. Hopefully with that demo, this graph is much easier to understand now. So we basically did a git init to get the working directory to become a Git repository. Then we did a git add, which added all our files into the staging area. Then we did a git commit, which actually saved the snapshot into our local repository. And we kind of followed this little circle for the majority of all of our examples. So the thing that we left out is the remote repository. And that's what basically GitHub is. GitHub is our remote repository. If you're a solo developer, a remote repository will allow you to back up your files and let you remove them from your local PC. Or if you're using a laptop, that's probably better because you don't want to hold on to all that source code on your laptop in case you lose your laptop or get stolen. If you're working in a multi-member team and you have multiple developers working on the same project, then a remote repository is absolutely necessary. I'm not saying GitHub is necessary, just a remote repository of some sort. This gives developers one central place to be able to do all of their merges. So it's one place where all of the changes can go. And since we have this concept of a local repository and you can do snapshots with it only from what's in the cache or the staging area, anything that you don't want to share, like you're experimenting with something, can be kept on your local PC, while the stuff that is actually necessary and needs to be merged can go up to the central repository. Git also uses hashing to be able to verify that whatever repository, local or remote, is being merged together, that it is actually the same repository. So it actually protects you against corrupted files or malicious changes to your projects because of the hashing. It's not really used for security, it's just used for file integrity. So in part 2 of the video series, we're going to talk about how to set up a GitHub account and how to sync it up with our local repository. If you have any questions, please leave in the comments below. Thank you very much for your time, and to my subscribers, thank you very much for your support.